Awesome. All right, so welcome everyone to Async Await in Swift. My name is Peter, and I'm a developer advocate on the Firebase team at Google, and I'm actually based in the Hamburg office, which is, I think, in that direction, not far from here. It's literally just a 5 minutes walk. People are always surprised to hear that Google has an office in Hamburg. It's actually not a small one, so we've got around 500 to 600 people there, mostly sales and policy and a couple of engineers. So most of my team are in the United States, somewhere in San Francisco or in Mountain View or New York, but we do have a couple of people also in London. But today, we don't want to talk too much about Firebase, but maybe a little bit, but instead about Async Await. So, asynchronous code is literally everywhere. So every single piece of code that you write that is not just a simple computation will have some asynchronous behavior. So if you're fetching some resource from the network, that's going to be an asynchronous call. So you make the call, it's going to take a little while, or maybe even a longer while, and while you're waiting for the call to finish, you don't want your application to freeze up. I mean, we've all experienced this. You have an application and then it seems to be doing nothing, right? So you tap on a button, nothing happens, and you always wonder, why is that? And the reason is that somebody didn't pay attention and they're basically blocking the main thread. So we want to avoid this, and this is why we need to use a couple of different techniques to work around this. And the most common approach to doing this is using completion handlers. And this code sample here shows that we're putting together a URL request for some API, for example, and then we're using URL session data task to execute this request. And then, as soon as it returns, we will inspect the response and act on it. So, we want to inspect the response and see if it has succeeded or if it has failed. And if it's succeeded, we can extract the data and then do something with it. So that is the traditional way of doing things in Swift, but it can quickly become more complex. So this looks a little bit exaggerated, and I give you that point, but it's there to illustrate a thing. So in this code sample, what we want to do is we want to fetch an article from a URL, then we want to extract the title from the HTML that we get, we want to extract the text, we want to extract an image, get the URL of the image, and then we want to inspect the tags in this article in order to, for example, say, oh, this is an article about, I don't know, about programming, and we want to use some language processing to extract how we want to categorize this article. And then in the end, we're putting together this article struct probably, and we send in all those parameters, the URL, the title, and the tags, and the image URL string, and then we call back to the piece of code that has called this process function. So that is slightly more complicated than what we had in the beginning, but what about if we add error handling? And this is really just like basic error handling, so nothing too fancy, and you can see that basically we're going in and then we inspect the result, and this is a result type, so it will either give us a success or a failure, and then we always want to react to that. So in this case here, it's very naive in that we're just printing the error message to the console, and obviously in a real-world application you would do something different. So you might be setting a status field on your service class, for example, or you might want to expose the error message to the user, so it will be a lot more complicated. And you can imagine if you do that with a complicated algorithm like this, it's quickly going to become really, really unwieldy, and it's hard to read and hard to understand what's going on. And even worse, it's very easy to make mistakes and then forget things. You might be forgetting an important condition. So that's not good. Wouldn't this be a lot nicer? So this code does exactly the same. So it downloads the article from a URL, it fetches the text, it extracts the title, it extracts the image URL, and it infers the tags, and then in the end it creates the same struct for the article to save in our database, for example. And actually, we can do this with Swift 5.5. This code here uses async await, and you can see here on this process function, I've marked this function as async, and that means it can be called asynchronously, and that means when the caller calls this function, the function will start working on a separate thread, for example, while the main thread can continue to do stuff like update the UI and essentially make sure that the application doesn't freeze up. And the way how this works is that it's at the call point we will create a so-called suspension point. And this part here where we call into fetch article, that is where we have a suspension point. So when I call fetch article, this as well is an asynchronous function, and at this point where I say await fetch article, I will have a suspension point, and that means that my function is suspended at this point while I wait for fetch article to return a result, and then execution will continue in the next line with try await extract text once it returns. So this is a new feature that Apple released with Swift 5.5, and this screen here shows you what you had to do before the release of Swift 5.5 in order to install this compiler toolchain. And I've added this slide here because nowadays you don't need to do that because it's built into Xcode. So if you use the latest version of Xcode, Xcode 14 or even Xcode 13, it's in there and you can use it straight away. But it's still educational, because if you want to use the latest versions of the Swift compiler, like literally like the development versions, you can still do this. You can go to swift.org and find this download page and then download the compiler toolchain and then add the compiler toolchain into Xcode, and then in the settings you can configure your Xcode instance to be using this compiler toolchain. So instead of using the release compiler, you can use a development version of the compiler to experiment with new language features if you're interested in that. So that's why I added those two slides here. But if you want to use async await in your code today, you can absolutely do so with the release version of the compiler. Cool. So let's look at a callback function. Let's imagine we've got a code base and we use a lot of those callbacks here. So I've put a very simple hello world, so it's easier for us to follow along. And this function takes two parameters. The first one is the name that we want to greet the user with, and then there's a completion handler. And this completion handler has one parameter, which is a string, and it does not return anything. That's why it says void. And then inside the hello world function, we call this completion handler, and you can see it's non-optional, so it needs to be present, so we can call it. And what we do is we send a string which says hello, and then we use string interpolation to interpolate the string that we got sent by the caller. And down below in the greeting function, you see how this looks like at the call side. So we call hello world, we send in the name parameter, and then at the end we've got this trailing closure which has this kind of simplified syntax. So it looks like it is just like an anonymous block of code that we will execute. And this result in means that we will receive a piece of information from this closure. So the result that we receive, that is the string that the completion handler basically sends. Okay, and then inside, in this case here, we just print. So very, very simple. OK, so to refactor this, Xcode does have a couple of refactorings, so not very many. Rename refactoring is the most prominent one, and everything else is really just bare bones. But for async await, they do have a couple new refactorings. So if you take the before code and then you open the code actions menu by holding down Command, Shift, and A, or using the right-click menu, you'll get a context menu, and one of the context menu items is convert this function into an asynchronous function. And what will happen is it will automatically rewrite your function, and instead of having this completion handler, it will change it to be using async, and it also adopts your the code that sends the return. So this is almost an automatic refactoring right there. And here you can see the changes. So before we had the completion block, and now we've got this async marker at the end. And then instead of having to call the completion handler, we can just return. So it feels very natural, very like normal programming, like what you would be learning when you just get started with programming. And at the call side, this looks almost like normal code, right? So the only change is that I have to say await to indicate that this is an asynchronous call and that I need a suspension point. So we make the call, and when it returns, we print the result. So that's great, right? But sometimes it's more complicated. So this is, again, just like a regular old function to fetch some data. In this case, we're fetching a user from this JSON placeholder API. And what we want to do is we fetch the data, then we use the JSON decoder to decode into a user struct, and then we call the completion handler. And if there has been an error, we call the completion handler with nil to indicate we didn't get any data. And if you think about it, that's not a very good API, because what happens if there was a real problem? For example, we did get garbage, or the network broke down, so we couldn't get anything, or there was a server error or something like that. So ideally we'd want to send some sort of error condition right there, so we'd have to have another parameter to indicate that error. Okay, but it's easy enough to call. So in the greeting function, we can see that we call getUser, we send in an ID of 1, and then we receive the result, we extract the information and print it. Very straightforward. But again, we can end up in this pyramid of doom when we have nested calls. Right. So how can we turn this into an asynchronous function? So we want to keep this entire function. Let's imagine it's very complicated, or it's in some SDK that we can't or don't want to change. So we'll keep this, and then we will write a wrapper function, and we'll call it getUser, and we make it be asynchronous. So it is async, and it returns this optional user. And I've already inserted the call to this function up there. So it says getUser. So this is pretty much the same as we had in the slide before. And now, in order to be able to make this call to the original function here, I need to wrap this in a continuation, and it's even a checked continuation. So what this does, it basically opens an asynchronous context so that I can make the call to a function that has a completion handler, and then when the completion handler returns, I will call the continuation and tell the continuation, all right, we're ready to continue because I received the callback from the callback handler. And this is what you see in this inner line, which says cont.resume, and then I'll tell it to return this result. So here's the continuation. Here is the result that we want to return. And then at the call side, it looks really simple because I can just call it as if it was straight line normal code. by saying await get user. No longer need to use a completion handler. It looks very easy, and I can get rid of all those nested calls. All right, so how does this relate to Swift UI? So you might have run into issues when you try to call asynchronous code from Swift UI, and the compiler might have said, you must only call this from within an asynchronous context. So, and to do that, so here we have a view, and inside the view we've got a function for adding some information to a view model. So it's called add URL, and I want to call the view model and call this add new article function. And this might be or in this case, it is an asynchronous call. So add new article is asynchronous because maybe I want to perform a database access, I want to access a remote server or something like that. So it needs to be called with await. But I can't just like call await within the add URL function. So what I need to do is wrap my code, my asynchronous code, in a task. And that will essentially open an asynchronous context, and I'll be able to make those asynchronous calls. Another thing that you can do is if you want to perform any asynchronous method calls as soon as your Swift UI view appears, there is a view modifier that you can use. So you can add this view modifier. It's called .task. You can add this to any view, and as soon as the view will appear, it will open up this asynchronous context. You can make the call, and the cool thing about this is when the view disappears, this task will automatically be cancelled. Now that's pretty cool if you have a screen that needs to load some data, but you want to abort loading that data if the user navigates away from that screen. All right, so a little bit of Firebase, and I use this as an example because Firebase, if you don't know Firebase, it's this backend as a service platform that has a lot of services that lets you develop apps faster, run with confidence, engage your users. And you might have heard of products like Firebase Authentication or Cloud Firestore, which is a NoSQL database, or cloud storage, and all of those. And all of those products have one thing in common. Every time you want to use them, it is a network call. So it's an asynchronous call. So you'll see a lot of things in Firebase that are asynchronous. So one example here is if you want to sign in a user, and there's an API that's called anonymous authentication, which allows you to sign in a user without them having to actually provide any credentials, which is pretty useful if you want to implement guest users. So this 3 lines here basically sign in the person who is currently using your application anonymously, so they get this globally unique identifier, which is not connected to any of their personal identifiable information or any device identifier. It's just like a completely random string. And then in the next line, I want to read the current user. And that is a problem, because it might be nil, right? Depending on how quick your application runs, this first line might not have completed executing. So if you check the current user, it might be nil. So what we instead recommend people do is use this sign in anonymously function and use a completion handler. And this completion handler will return as soon as the sign in function has completed, and it will give you a result and an error, and then you can check if everything went well, and the result contains the user. So that's what you should do. But for most people, it's really inconvenient to do that, right? So they want to write straight line code instead of using all those completion handlers. So one option is to use combine. And here you see how you would use combine in order to call sign in anonymously, then wait for the result to come down the pipeline, map this user, replace any errors with nil, and then assign the result to the user attribute on your view model. So it works really well. but not everybody might like to use combine. And for people who would rather not use combine, we now support async await. So let's look at this again. And in the example at the top, you see the callback style, and in the example at the bottom, you see the async await style. And you can see that it is so much easier because you can just call it in straight line, and it only just looks a little bit more complicated because I implemented error handling. So obviously, this call can fail. So we want to catch errors, and if there is an error, we want to do something about it. In this case, we print it. But if things go well, we can just continue execution and then do something with the signed-in user. So you might be wondering, how complicated was this for the Firebase team to migrate their entire code base that had like literally hundreds of completion handlers to async await? And the answer is next to nothing. So we got really lucky because Apple was in the same boat as we were. They have a massive code base that makes use of a lot of completion handlers, and most of their code base is written in Objective-C. Most of Firebase also is written in Objective-C, and this is where he got lucky. So there is a Swift Evolution proposal. It's Swift Evolution 0297, and it basically says how the interoperability between Objective-C and the Swift concurrency model looks like. And it basically says, if you have a function that has a completion handler and the name of the completion handler parameter is like one of those 15 names, then the Swift compiler will automatically turn this into an async call for you. And you can call this function from an async context. So this is a snippet of Objective-C code that shows how the sign-in anonymously function looks like in the Firebase SDK. So this is open source. You can have a look at that. Just go to the GitHub repository or use the Google code search, the open source code search at cs.opensource.google.com. And this piece here shows the function, and then at the end of the line, you'll see this fear auth data result callback completion. And here's how this looks like. And you can see that it has two parameters. One is the result, and the other one is an error. And the Swift compiler will basically say, all right, so I'm going to turn this into an async call because the name of this completion handler is completion. And it's got an error on it, so it's throwable. And that means you need to call it with try await. So if you want to learn more about this, here is a blog post I wrote about it. All the various ways how you can call Firebase APIs using the various asynchronous mechanisms, for example, completion handlers or async await, and also combine. There is a video that goes into a little bit more detail and shows some of the things that I showed today in action. And that's it.